show you like a hint of how you would find what this should be in a different way. T goes to t to the 2/3. This is my transformation. What would dt prime be? 2/3 t to the minus, right? All right, dt is 2/3 t to the minus 1/3, right? What would dt prime square be? Square that and get to the minus 2/3, which means 1 over what it was before, which is 1 over r. Right? So dt prime square will be proportional to 1 over r. And that tells you that the factor is the potential, 1 over r. ds squared is equal to c dt squared plus the spatial part. I'm just going to have some function in here, which is the potential. Keep c the way it is, and like that, which is what we do. That's this. You do all these constant factors, you're going to get exactly gm over r. And obviously this constant has to be 1. So taking Newtonian gravity very seriously, taking the equivalence principle very seriously, just looking at this radial infall, t to the 2/3, if you say no, it's not t to the 2/3, it's got to be alpha t, because it's a straight world line because it's inertial, right away tells you time is stretched, and tells you that the factor is the potential, 1 over r. So you can kind of collapse this whole hour and whatever into those few seconds and say, okay, immediately I can see from the equivalence principle that I'm going to have a space-time metric and my time is warped and I'm going to have 1 plus something over r. And that's, of course, the Schwarzschild solution, except for the fact that we don't have spatial curvature. Einstein's original theory, or one of the theories that he was working with before 1915, at 1913 he came up with what's now called the Entwurf paper, the Entwurf metric, and this is exactly the metric that he presented, with a flat space over here. You see clearly here that the amount of time passing will be different depending on the potential, but you can also see it from here, and you can see the amount. It's like t to the 2/3. In other words, you're going to have a factor of 1 over r relative to the previous one. There's a time stretching, which if you do dt, the dt square, which you have over here, you need a factor of 1 over r. And in fact, you can do this in your head as like by inspection really.